Okay. Hello, everyone. Welcome to our panel on ZK rollups and the future of ZK rollups in context of potential Cloud 2.0 solutions. Before we start with the questions for our guests, we'll first introduce our guests. Actually, they will introduce themselves. So first, Edi, Cathie, and Andrija.
Yeah. OK, thanks a lot. So I'm an ex-Ethereum core dev, mostly working Solidity, but been in ZK space for like 5 years now, researching it a bit. And most recently, kind of last 3 years, been like working in Starknet ecosystem. We have a strategic partnership with Stark. We're like a bunch of stuff from protocol to dev tools to devs and so on. So deep into the rabbit hole.
Right. Hi, everyone. I'm Cathie. I'm currently a zero-knowledge machine learning researcher at PSE, Privacy and Scaling Exploration Team. It's a team at Ethereum Foundation. So I've been doing a lot of kind of like infrastructure research, like how do we actually speed up to do machine learning in ZK so that we can actually make it like possible for the users.
Yeah, and I'm Andrija. I'm cryptography researcher at Geometry, also focusing mainly on snarks and zero-knowledge stuff. So yeah, happy to be here.
OK, thank you. So first, let's start with the basics. So Edi, can you explain us a bit what is ZK rollup?
Sure, yeah. Like in general, like maybe we can do a distinction between optimistic and ZK rollups, maybe Validity ones and so on. So I assume most of the audience here knows about optimistic rollups. You've used it. Maybe if somebody wants, did you use like optimistic ones? OK, we have decent amount of heads in there. So with optimistic rollups, we have a rollup and we have fraud proofs that are posted kind of on layer 1. The issue with that usually is it takes a week or so, maybe more or less, depending on implementation. But we have a lot of delay in finalizing this on layer 1. With ZK and this specifically Validium rollups, it takes much less time because the cryptography improving process is kind of different. So let's say that we have Validium ones, which are non-privacy oriented, and then in the end, we have a ZK ones, which are actually with the privacy embedded, like Aztec, like Aleo, and some others. So yeah, that's. But the ZK rollup in its kind of core is you have a rollup, and you have like this proving technology that kind of generates proofs and hypotheses on layer 1 with a math that is a bit different than just the optimistic one. But yeah, that math is kind of.
Yeah, so the ZK part is actually there to prove that each state change is correct between blocks, but in general between different states, the transition is correct. So, Cathie, can you tell us maybe, do you see any technical challenges regarding the zero-knowledge proofs that are used for those rollups?
Right. So well, in order to scale using ZK rollup, the property that we're using is that the proof size, when it's verified, is very small. Right? That's why we can do it very quickly in L1 Ethereum. But the challenge is that the prover time is quite long and significantly computationally extensive. Right? So actually, I think one of the biggest challenges that ZK rollups have is, first of all, sequencing, because it doesn't make sense for people to be repeating these computations since it's very expensive. Right? So how do you actually delegate like different nodes to do these proving so that you can then verify? I think that's like one of the biggest technical challenge that we're facing with ZK rollup.
Yeah, so from the implementation side, we have those challenges. Do we have any challenges from the side of regular user that would like to run a node of this kind of rollup? So Andrija, can you tell us a bit of the challenges regarding the running the node? So are the resources that are required?
Yeah, so in order to have like a huge scaling and to put a lot of transactions in that transition function, you need like a lot of RAM. You also want to use some very well audited hash functions, which are still not ZK friendly hash functions. So you have like the huge now scalability problem, and you as a prover, you spend a lot of time actually making proofs of something that is currently very cheap on normal computer. So yeah, like we also should see some shift in how we measure gas, how we measure what is actually hard, what is not when we switch to that system.
Yeah, so definitely we see the value of those rollups, but we also see there are challenges for running the rollups, and we also have technical challenges. So another technical challenge may be using proofs that require trusted setup, for example. So where are we with this? So Cathie, can you tell us?
Yeah, so trusted setup is probably a thing that people hear over and over again. Some of you might have heard of like the KCG setup ceremony that Ethereum is running. So basically, there's a lot of different proving schemes that you can use for ZK, and some of them require what we call a trusted setup, which is like for a particular computation that you're doing, you need a bunch of people to provide this like randomness, so that to guarantee that the proof is not tampered, right? So basically, the idea is if you have some randomness that people already know fully, then people can essentially tamper that proof if they know that entropy fully. So the idea is, well, if we get a lot of people to do this trusted setup, then unless there's some malicious attacker that knows everyone's contribution, otherwise it's not able to do so. So the more, I guess the more specific the trusted setup is, usually the trade-off is that the proving is cheaper, the verifiers is also cheaper. So growth 16, for example, is like you have to have a trusted setup for every single computation that you're, different type of computation that you're doing. But recently, we also have like more universal system like Plonk, where you just need a universal setup, right? So one setup that, for example, just similar to the KCG ceremony, like that millions of people contribute to, then we can reuse that over and over again for ZK. Yeah, but this is definitely a kind of trade-off, like whether there's trusted setup or not. There are other ways like Zcash. They use totally a setup that doesn't require trusted setup, but then you have even longer proof time. So I guess that's the other technical challenge we're facing.
Yeah, one of the interesting rollups is actually our ZK EVM rollups. So we're trying to emulate the functioning of Ethereum virtual machine, but using the ZK proofs. So how do we do that?
There are like different kind of approaches, but yeah, like, so we have like maybe two, just to go step back maybe on Snarks and Starks, like you have a trusted setup usually in Snarks, but there are also technology called Starks, which kind of removes that. Obviously there is some overhead due to that. So it's not only that we need to use like, Plonk and universal setups, but we also can use the Starks and so on. They have their other disadvantages, but yeah. So maybe to go from there, so what we have also on the market is ZK VMs, which is virtual machines, and ZK EVMs, which are kind of Ethereum virtual machine. Why would we want to use like Ethereum virtual machine? Well, a lot of people already used to that stack. We have dApps developed and so on. But the issue is that usually the hash functions and so on are not really ZK compatible or ZK friendly. So we have to create some kind of conversion from the Solidity code you have into the like EVMs, like ZK EVM that you have underneath. I think Scroll uses the bytecode compatible one, or like we have a guy from Scroll here, so maybe he can jump in. But yeah, we have like different kind of levels of compatibility with like in ZK EVMs. I know like ZK Sync basically doesn't have full compatibility, so we have issue on that, but Scroll does. But I'm not sure what kind of is the biggest difference on those kind of things. Maybe Cathie, you know there?
I'm not familiar with like the actual technicality, but you're correct that Scroll is at least currently 100% compatible. And then with ZK Sync, there's a little bit of difference. But just writing on the bytecode thing, when discussing with Scroll, actually it's a very interesting problem. Is that, like, let's say there is an upgrade in EVM, like Ethereum itself, there's always a delay when you're going to get a 100% compatible version in ZK EVM, right? Because like, it doesn't directly translate. So I think that's also would be a quite interesting issue that we're going to be facing in the near future when there's upgrade to Ethereum.
Yeah, for sure. I'm personally proponent more on the ZK VMs than ZK EVMs, because EVM in its own core, back at the time when it was built, it was like really good system, but we've seen some of the inefficiencies of it and so on. So we have a trade-off if we want to target, let's say, 1 billion users in the future. Do we use this legacy system and build a top, which have an overhead, or do we go with a like completely new stack with its own issues, like Cairo, like and new language, completely new virtual machine, and so on. So these are some of the trade-offs we have to take into consideration. But good side is we have multiple teams building this with different trade-offs. So we'll see what survives and thrives in the future.
Yeah, also one of the interesting things is that if you want to prove that the state change was correct, you submit the proof to Ethereum blockchain. But for all the smart contracts, you're mostly using a Groth16 prover because it's actually the cheapest. But internally, some ZK EVMs use both Starks and Snarks. So we have multiple provers to prove that the computation is correct and that the proving was correct, probably. OK, so we see that ZK rollups are getting more popular in general. There are use cases for them and so on. We also say, when I say ZK rollup, we say ZK between state changes. But is there any ZK in the blocks themselves? If we talk about rollups as blockchains, subchains, so is the data hidden inside blocks, or is just transition different? Is just transition hidden?
So,
you can go. Yeah.
So, like, I know, like, the ZK sync and both Starknet just post a state diff basically to the mainnet. So what that means basically, if we kind of do, I don't know, like we do 10 interactions on a layer 2 on the rollup basically for a specific thing, only the difference between the first and the last basically state will be posted on layer 1. With, I think scroll does, it also does, okay, and like, so most of the systems do just post the difference or not, if you know.
Not sure.
Or no, okay, ZKVM from Polygon posts all the transitions of state, if I'm not mistaken. So we have that. Sorry? Scroll as well, like all the transactions. Okay, good to know. I learned something new today, so thanks. So, like the conclusion basically, ZK Sync and Starknet do just post like just a difference in state, and others basically post the other transactions and transitions.
Okay.
So, yeah.
So we have the ability still to see the data. It's not zero knowledge hidden. Okay. But we need to have zero knowledge proofs to confirm state changes. Okay.
Exactly.
Well, ZK rollups in general are one of the leading scaling solutions for Ethereum, and the idea is to introduce decentralization to a wider audience, if we can say it like that. So the idea is to maybe switch from existing clouds to something more advanced or more, let's say, verifiable. Where do you see, or actually do you see the potential to reuse zero-knowledge technology to something that can surpass current problems with cloud and become actually something that is now called Cloud 2.0? So, Andrija, can you?
Yeah, so I guess we have two sides there. One side is what Cathie mentioned about like ZKML and just being able to verify all the models and some huge computation that you're getting from the cloud. And different side, you can also look at like computation delegation, where actually you can build your huge cloud, like very powerful cloud, from very small specialized chunks that are independent. So instead of one cloud having to run terabytes of RAM machines to be scalable, you can actually have many small players who run some specialized part of computation by like designing like specialized hardware or data centers or whatever just for a specific task, and then a part of some huge computation can be delegated to them, and that whole, so to say, graph of computation in this kind of BCD settings is fully verifiable. So you don't need to trust any party in this whole splitted cloud, so to say. And you can very efficiently produce the same computation without actually having to care too much about scalability and having some machines running when they're not have what to run, and like it can reduce the cost of a fully centralized cloud a lot. without compromising the results or anything like that.
Interesting. So ZK will actually introduce verifiable computation to
exactly
networks. Okay.
Exactly.
So yeah, Cathie, you are also involved in ZKML, so zero knowledge machine learning. Do you see any potential of using a zero knowledge machine learning in the environment that could work as a cloud? So I can submit a query like image, and the network will be able to answer me to that query by doing some computation domain of machine learning on the image, so classification, segmentation, and so on.
Right. So, well, regarding this verifiable computation, I guess the biggest challenge is, of course, if we can run it on the blockchain itself, that would be great, right? And even when we talk about rollup, when we talk about scaling, we're scaling the ledger, right, not the computation side. So my personal take is that, yeah, so what definitely ZKML is one thing, or really just any computational heavy applications, it's actually best to take it off-chain and have some form of ways to do verifiable computation. So I think ZKML is just a very small chunk of it, right? Because machine learning ultimately is something that is probabilistic anyways, so you don't have full 100% accuracy, right? So there's only so much you can do with machine learning. But there is a lot of other things that, for example, anything that is role-based, algorithm-based, things that we might want to have a result to commit to a blockchain. So one of the example I gave in earlier today's presentation was actually like algo trading, right? We can easily have a verifiable algo trading if we are able to achieve verifiable computation. So I think the power of like taking all these computation off-chain, but then at the same time being able to verify on this ledger that we have a strong consensus, global consensus, is a very powerful tool.
So do you see the possibility of utilizing ZK without blockchain in this constellation, or you think that the blockchain is the basic foundation that needs to support such use case?
I think it will be kind of a network, or a network of network, actually. So computation would be a network of itself, but we still need to rely on like the ledger itself to have some kind of consensus. So the way I think about it, especially Andrija used the computer analogy, is that like you can think of maybe the ledger or the block time itself could be the clock that we're clocking our computation, right? So how do you have a universal, like let's think of it as if we have a bunch of decentralized computation, how do you even define time? It's a very interesting question. So I think like the idea of having a consensus is actually very important. It's like the clocking of our computation.
Yep. So in general, it doesn't have to be a blockchain, but there needs to be some kind of consensus that will synchronize the network to be able to operate like that. So Edi, do you see any potential use cases for a system like that, besides zero-knowledge ML that we just mentioned? Some practical use cases for general population?
So like, yeah, one of the like things that kind of has been developing outside DeFi, NFTs, and so on is kind of gaming. So usually like it's currently primitives, you have on-chain games and so on, which are kind of, you have a limited capacity of ledger, consensus is like expensive to achieve and so on. And potentially what you could have is you're playing some off-chain game that you know how it works and so on, and you buy some item or whatever, you can generate a proof, settle it on-chain, basically you have some item that you want to trade or whatever. So it's kind of a hybrid potentially that, you could still have a marketplace on-chain which is kind of trustless and so on, with in-game kind of inputs and stuff. So that's one potential thing, but obviously, from cloud computing, in general, you can kind of prove any computation. But more user-facing stuff that you will see. Also, identity is kind of one of the biggest kind of questions. Like I just had a chat with the Polygon ID guys. Basically, there's so many questions and not a lot of answers, because in Web 2, the identity, for example, is not solved. But theoretically, if you have those fractions of identity, we kind of combine them. We could have an on-chain basically identity which consists of multiple of those. Also, like the idea is if that is also good because they're trusted kind of parties and so on. But anyways, we could have those kind of hybrid models that kind of play hand in hand basically with this.
Cool. So from the user perspective, again, I as a regular user may use a mobile phone with, I wouldn't say slower hardware, but compared to PC or any other server, it's a slow hardware. So does that mean that we can use a mobile phone and request some computation which is a lot heavier than the phone itself can fulfill, submit it to the network, and the network nodes will, I say network nodes in general, I don't have any idea of the architecture, but I think about the nodes will perform the computation, answer to me, and I will be able to verify those results some way. So do we see any incentives maybe for operators of those nodes? So any of us may use our own resources to utilize the free resources on our computers to support that kind of network. So do you see any way to incentivize those people or whatever? In general.
Incentivize the people who run the cloud, or incentivize?
Yeah, to run the nodes that will form the cloud, the virtual cloud, because cloud.
Yeah,
right
so I think that by just having the ability to have some very specialized part of that whole cloud will allow you to lower your cost, to have better approximation for scaling, to better utilize your resources, and yeah, you should have a lot of incentive to be a part of some, let's say, bigger cloud.
So as a user of a cloud or as a node runner, who will support the system? Yeah.
So I think both. But I think we should start from the perspective of node runner, which will be able to contribute to some huge scale system, and without needing to have full data centers around the world in order to just be the part of that. And as an end user, whenever you have some important computation that you cannot easily verify, that gets the value to you or your company, I feel that you will be incentivized to just get a proof that it was run correctly. And yeah, we should distinguish between the computation that you expect the proof for. Maybe we can look at ZKML stuff. So if you have, I don't know, network which generates you the pictures, and if you submit some request, you get the picture, you yourself can vote or resolve, is this good or not enough good for you, without actually caring how that computation was done. But if you have some NP problem, like some optimization problem, or you have a service which optimizes your logistics, so to say, and you put some parameters, you get some result, you cannot actually be sure how good that computation was. And was it done on some lower model? Maybe it was just a guess from this cloud. Whatever. There is so many ways how they can make their life cheaper for just putting the wrong results on your site, or not optimal results. And this is the part which you would like to have some kind of commitment from that cloud or that company on which you can verify that results you're getting are at least what you're paying for.
Maybe, yeah, I think we, let's go back, basically. Let's forget about ZK and so on. Let's go back to Ethereum. So we have an issue in incentivization of full nodes, light nodes, and so on. That's kind of the biggest issue. So I think the solution is kind of twofold. We should incentivize also those kind of part of the infrastructure, not just the validators, not just the ones who are producing the block, but also the ones who are kind of, watching this, syncing the network and so on. And the other basic part is making light nodes lighter, so you can run them on your mobile phone in a browser, so you can verify things really easily. So, but obviously, printing more tokens is not really a solution. So, also with the ZK kind of stuff, it's hard because you still have one prover or one sequencer at this point in the development of the space, so they are kind of trusted and so on. You don't have this overhead, which is a feature basically with POS consensus, says that multiple kind of parties can verify this full state and generate the whole thing and so on, because it will be too expensive, as basically Andrija said. So this is more than an open question than the answer, to be frank, but yeah.
Yeah, I think like regarding incentive for running like a compute node, I think there's a lot of incentive. People are paying a lot for Web2 cloud services nowadays anyways. Definitely it will be more expensive in the Web3 version, at least in the short run. I think maybe, to me, probably the bigger issue is whether there's incentive for the user to use this Web3 version of the cloud over a Web2 version. Right? So there's very trusted cloud services in Web2 nowadays. Like, why would they pay perhaps maybe 100 times more expensive for a Web3 version? So it depends on like really how much we believe in the don't trust, verify kind of point of view. But yeah, I see that maybe adoption could be a bigger issue here than asking people, giving incentives to run like compute nodes.
We kind of have user experience currently of blockchains is not really the best. So yeah.
Yeah, that's actually a good opening question for the next question. So today we use, let's say, Gmail, we use OneDrive or so on. We use a lot of cloud services on our phones or any other device. But how far are we today from transforming the world where we use Web3 cloud services on daily level? So when I wake up in the morning, I want to open the mail, which is hosted in some decentralized environment. I would like to store files in some decentralized file system. I would like to stream videos from decentralized system, and so on. So today we rely a lot on Web2 cloud services. But what is the state of cloud services on Web3 today? So.
Okay, I'm gonna start with just a little bit of, like, I guess, personal view. Is that, like, personally, I don't believe that everything needs to be Web3, but as long as there's an option to, right? So you say, Alex, email example. Actually, nowadays we have the option to run our own email server at home, right? There are people who are doing that, right? So as long as there is the option, the alternative to do that. And I think it goes the same thing with all the other things that you're talking about. And I believe there are a lot of other projects doing it in a decentralized way, maybe not utilizing ZK. But ZK could be a way that is more, I guess, trustable by the user without a lot of overhead of actually redoing the computation. So like it's just a way to condense this trust other than like having the user to understand fully and do their own indexing, look up all the data. I see that like it could be a supplement to all these already decentralized streaming. What other decentralized services are there? Streaming, P2P messaging, et cetera, et cetera. But like ZK just kind of add that verifiability in a more efficient way.
Yeah. Does that mean that in the future we'll still have clouds as today, so Web2 cloud and Web3 cloud only for specialized services where trust is important? I mentioned those few use cases like file storage, email, and so on, because there are solutions today that actually focus their business models to that side. So what would be, maybe the question for Edi, what are the obstacles on our way to get to the Web3, at least subset of cloud services on Web3? So what are the problems for adoption a system like that?
Maybe demand for that, because currently we're still playing kind of with Legos and so on, inventing new tokens, like, okay, DeFi was one of the biggest use cases because finance is completely broken in Web2. So, we need this kind of system which is trustless, so that's part of the story. We had NFT summer, like different iteration and so on. I believe in the future, this kind of ownership potentially will be the next wave and so on. But for the cloud compute and so on, gaming could be one of the biggest things basically that drive this. The main question I have there is what kind of stuff do we need to put on chain and what stuff, we don't want to kind of trust to these big AAA companies and so on, and also the time for that. Time to market basically for one AAA game is 5 years. If they even start building it now, in 5 years, maybe we'll have demand for this. So, we're basically building for the future that may come. So that definitely is needed. But yeah, maybe ML models, maybe same AI is kind of a big term, but yeah.
Yeah, and what you started asking about decentralizing some parts of the system. So I think that before the whole verifiable computation, decentralization was a way to fight a party which has a lot of data and that is able to bias the results in any way, like by serving which data it's serving, to whom it's serving, and kind of decentralizing any of those systems was a way to fight that no party in the system can bias the results. For example, you mentioned like streaming services or like social algorithms or whatever. But now with verifiable computation, it's also, maybe we should just not decentralize that. If we have like public models that you can verify, or just not models, just like algorithms that are, if you can verify that they're being run and you can check that they're like not biased or whatever, you should have much more confidence in that service without necessarily decentralizing it and fighting with all incentives that you just get by entering and putting more parties into some network or system.
Yeah, there's always a level where we trust. Is it like software? Is it like hardware? Is it like, because you know, like it's always a trade-off. Okay, do we want to build our own hardware so we are like secure that this is not tampered with or that it works actually as we want? You know.
Yeah. Do you see maybe any domain where the entrance of Web3 cloud will be the quickest? So where will be the first entry point for Web3 systems in commercial way?
Like it's like this kind of verifiable computation, basically, that you mentioned, like with, you know, now AI being a hype and so on, it will probably mature into like there's a lot of open models and so on. Still, we need to have a huge, you know, clouds for this, but we want this stuff to be as verifiable as possible, although it's all probabilistic. So the question is, how are we going to verify it? Because, you know, we usually don't know what's under the hood. So yeah.
Yeah, no, I think I truly have. I think the domain where fairness is important is probably the most important for verifiable computation, as well as, you know, Eddie just said, like, no one is always going to look under the hood, even though if the hood is openable in a way. So like social media, like Twitter open source their whatever algorithm, who's going to really look into it, right? All users really care is whether this algorithm have been fairly applied to you and me and, you know, everyone else. Right? And actually, in that case, like, even though ZK seems like such a mystery thing, I think it's actually the opposite in this case, because it's very easily verifiable in terms of assuring that the same computation has been done to everyone's data. Right? I don't need to understand the math. I only need to see the proof that it's exactly the same computation done on everyone. So I think, like, you know, whenever fairness is very important, then that domain could probably adopt this verifiable computation the most, probably the soonest.
Yeah, now when we use our cloud services, we submit data to some other centralized entity, which follows certain rules of the country where they are situated. And if any data loss or any data breach appears, they're reliable. So do we see any problems here with decentralized clouds, where you submit data to the network and every node in the network can actually see the data? The data is transparent, but on the other side, if some data breach happens, who is responsible? It's a difficult one.
Yeah, that's quite a difficult question at this moment, but maybe you should still start with an entity that actually has the data, and other entities are just like executing the parts of the computation before you go to this even harder part about decentralizing the storage and storage proofs. And yeah.
So reducing the computation on the low-level side, where the data is maybe indistinguishable from the inputs that are sent, can actually solve the problem where every node participant has some chunk of computation which is anonymized, and then returns the result. Or maybe if the data is already, it is okay for the data to be transparent. So you submit data to the network that is public data, then there is a potential for the system. But do you have any idea if bigger commercial companies will be glad to change their corporate systems that are in the background of their companies to something that will technically make their data leave the company and move to some other entities like small companies or actually physical participants like us here? How glad will they be?
Yeah, no, I think this is the time at the panel when we say ZK is not the solution for everything. And I mean, it is true, like when it comes to data privacy, you know, as Andrija is saying that when we talk about ZK, essentially the prover is the data owner. And that's why there's also other technologies that's being developed, like fully homomorphic encryption, you know, MPC. So I think unfortunately, to be frank, there might not be a lot of incentives for those Web2 companies to disclose those data. And then that would mean that we probably have to wait until like other tech to be you know, developed before that happens. But like within, I guess, at least within what we can do right now, then there are still a lot of use cases that can make use of public data and verifiable computation.
Yeah, maybe like some of the experience we ran back in 2017 also, like this was like one of the companies basically we ran this, it was a consortium-based chain, like based on Ethereum and so on. Why they do that is basically because part of the state is private and so on, and only they have access to that. So, but to go step back basically to explain what the issue was, so this was like the huge company, like global one, with multiple franchises in multiple countries. Each of those franchises behave like kind of a separate company. So when you want to access from one side, so one island to the other, basically, you need to request, you know, access. Somebody has to approve it. And the issue with that is like the basically computation and entities are separate. Somebody has to approve that, then you have to audit that. And then what happens? Sometimes somebody gives access to stuff that is sensitive. They get sued and so on. And the idea basically here was to create this kind of verifiable, like you have a consensus at the top. So it's final. Blockchain is a mutable database that nobody can tamper with. And the idea, like back then, we didn't have ZK like in production, but today, like we could improve those kind of things a lot. Where okay, you generate a proof that this was in your database, someone accessed it, and so on. You have a prover as one of the entities. Anybody can verify that it's actually been done, but on the other hand, they don't see the whole data and everything because it's on their data availability, you know, committee or whatever. So, does that make sense? That's kind of maybe, but you know, this is maybe what will kind of be the next iteration of experiments and so on more enterprise/consortium basically chains. So yeah.
Yeah, we can conclude that there are still some obstacles and there are still problems with adoption, but also there is a potential for such system in specific domains will actually add more value than Web2 systems. So adding a trust to some Web2 service currently run by some centralized entity. With Web3, we can add additional value which may surpass the costs of running such systems. Oh, as I see, we are a bit running out of time, so thank you all for all the nice answers and all the potential answers to the questions that are currently pretty difficult to answer, but we have a clearer picture now. And yep, thank you all. And we can switch to questions from the audience. Here? Where is the mic?
Yeah, in the dark room. This is kind of a ZK, you know.
We have a microphone.
Yeah, sure.
Yeah,
we can repeat the question, so feel free to ask.
No, sorry, there's a question in front.
There's a question, we'll repeat.
Sorry.
Sorry.
Can you please just wait, you know.
You're next.
Yeah. maybe repeating the question. So.
Oh yeah, the question was if you can imagine the use case where you can rent your hardware to anyone else, so to the network in general or any other participant. How do you see such a use case in this Web3 decentralized clouds?
So I guess that's something we already mentioned, but like my take is that it should not be that decentralized, because still I feel that some parties will have more incentive if they really specialize to very specific kind of computation. Before you can have like the full open marketplace where you can submit something. And
yeah, I agree. Like, you usually need some specialized hardware for this kind of things that will be high in demand. Maybe for this kind of like things, I don't know, you have some GPUs that are a bit better, then you can get price for that. But yeah,
it's the matter of better distribution of resources, right? When it's too decentralized and too P2P, then it might not be the most efficient way of doing so.
There is a speed of light limit, with propagation of information, so that's also one of the limits.
Yeah, there is a limit how much you can parallelize something until the communication becomes an overhead.
Exactly.
Okay, we had a question in the back, I think. Oh, we have a mic.
Perfect, thanks. I would like to ask about hash functions that are used currently and will be used in future, starting from Poseidon. We have Poseidon 2.0. By the way, we as a company participate in research on Poseidon as well as reinforced concrete. And there is also TIP 5 and Rescue Prime. So there is a variety of hash functions out there used in completely non-standardized way. In particular, because most of them, like Poseidon hash, are very parameterizable. So my question would be, from performance versus security perspective, which one would be, in your opinion, a winning one, if possible? Because that would be very important when it comes to standardization in future and possibility of putting all these proofs in ASIC, for instance.
Okay, I'm not sure if I heard the whole question, so if I missed something, please fill it. Yeah, so regarding hash functions, I think all these ZK-friendly hash functions are very new, and for like some currently system in production that it is not that easy to just replace SHA, Ketchuk, or Blake with any new hash functions until certain period of time and auditing passes. So yeah, I think it mainly depends on and at which state your system is and what are you trying to achieve, because what we were speaking about, like EVM and having the network to be verifier, you really want to have as fast as possible on the prover side, which smaller proof size and like non-linear verifier, to say. So yeah, I think it just like it really depends on the whole system and at which state it is.
Also, like one of the things I would like to add is like, okay, there is new fancy things, but if we didn't test them in production, we don't know if they have a security flow. And with this kind of things, it's a trade-off. Do you want something fancy new that's much better, or do you want something that's stable or something in between and so on? So
exactly. And
kind of Poseidon is currently maybe in perfect spot, quote unquote, but yeah. It's
and for a very like specific use cases, I think it's not very popular now. Maybe that's people not considering different kind of ZK proof systems, which are not coming with this magical snark word, where you actually can do very efficient SHA or Ketchuk in like MPC in the head setting, where your verifier will also like not be succinct, but will be extremely fast if you're not running EVM or like on a just normal machine that is verifier. So yeah, I think that's also something that should be considered if you're actually if you still want to use like SHA or Ketchuk, and you don't want to go in this like VM kind of setting.
Yeah, and the hash functions that are used for ZK were not invented to to be better in security perspective, from perspective of security, to be better than SHA-3, but to be more efficient for circuit computations. So that's why those arithmetic hashes are used instead of bit hashes that like SHA-3. So starting from that perspective, we can see that arithmetic hashes may be slower. I mean, will take some time to achieve the security of SHA-3 functions, but for efficiency purposes, they are good enough, let's say. Yeah. And the time will show which exact hash will be the winner, like the best. But
it's probably not winner takes all. You know, like there is no one solution that like wins over this.
Absolutely.
So yeah.
Yeah, I just want to share a very quick use case that I actually use SHA-256 in some of the CKML circuits. And I get asked a lot, like, why? Actually, everyone who read the code is like, why are you using SHA-256? I'm like, well, that's because there's also integration with other things, right? So in particular, like if the data is hosted on IPFS, actually they use SHA-256 to generate their piece ID, the CID. Well, then you kind of have to integrate with that, and it's not very efficient to have like 2 different set of hashes to try to verify the same thing. So something like that.
But for specific purposes where you have to achieve a certain level of security by some standards, you are required to use verified functions like SHA functions and so on. And that's where you don't you cannot ask the question which one should I use, but the one that's on the list.
Exactly.
Yeah. Okay. Do we have any other question?
I think we have there.
So correct me if I'm wrong. To generate these ZK proofs or ZK circuits, you need quite a powerful hardware. And will that not be the same what happened to Bitcoin, that this ASICs wars started and they tried to implemented new hardwares, created new hardwares that were more efficient, and that is now the main topic, that they are very efficient, but not efficient in the terms of energy consumption. It's consuming a lot of energy, and Ethereum is now proof of stake and doesn't consume much energy, but now the layers 2, this change in layer 2 will have the same effect, that it will consume a lot of energy because of these ZK proofs and ZK circuits.
Yeah, maybe I can take this one. Like from the decentralization perspective, I don't think it's the same problem, because like with miners and so on, you had a competition. So the bigger amount of hash you had in a system, the more secure the system is. Here it's not inherently like because of that. And some of the designs I've seen on the centralization of sequencers and provers, it will be on the range of 10, 100 or whatever, but it will be more or less capped and so on. So you will have an overhead and move towards more special hardware and so on, but probably it won't be uncapped, or you won't have unlimited amounts of miners that are doing this kind of stuff. So I would say that on one hand, this is kind of a proof of work where you have special hardware, the better hardware you have, potentially faster the proofs you'll generate and so on. But on the other hand, I don't think this on a consensus level will be uncapped, because you don't basically need this. And also you have optimistic parallelization of proving, which kind of you give a chunk of the proving to each of the basically machines or the hardware, so that way you don't have an overhead that you had with proof of work, which everybody basically kind of generates a proof for the whole thing. So yeah.
Okay, seems like the time is up, and thank you all for listening. Thanks to our guests that introduced us a bit further into cloud technology on decentralized systems, and that's about it.
Yeah.